All right. Hello, guys. So we're going to go ahead and do our third lesson of this module, which is going to be about accuracy, precision, and percent error. So first thing, if you can go ahead and put your phones away, and if you haven't already done so, go ahead and complete the bell ringer in Canvas. Once you're finished with that, you can unpause the video and pick back up. So go ahead and do that, pause the video, come back when you're finished. Okay? Alright, second thing you're going to do is go ahead and open up a new tab and go to the website joinpd.com. And once you're there, it'll ask you for a code, and you're going to type in the code up here on the top right. That's ECVIL. Go ahead and type that in, and it will allow you to interact with the presentation, answer any questions that I'm going to ask throughout the presentation, and it just gives me a sense of who's doing what, allows me to give you some good feedback so that if there's something that's particularly difficult, I know about it and can help you as we go. Okay, so this is a mandatory step. Make sure you guys are logging into the presentation. That way, everybody's accounted for, okay? So go ahead and do that. Pause, come back whenever you're ready. And then the next thing is go ahead and get out paper and pencil to write down notes, questions, and work example problems. Again, as you write things down, it just commits them to memory a little bit better. So go ahead and prepare for that, okay? And let's jump right in. So we are still in Module 0, and this is still measurement. And today we are in section 0.3, which is accuracy, precision, and percent error. It sounds like a lot, but really it's not a whole lot. As you can see down here, it's about 18 slides, so we'll get through it fairly quickly. Okay, our objectives for the day. Number 1, distinguish between accuracy and precision. And then number 2, calculate percent error given laboratory data and reference values. So we will be doing some calculations in this section, just like we did with scientific notation last section. Again, this is the measurement module, so it's expected that there would be at least a little bit of math. Okay, so you can't escape it. Just because you're not in math class doesn't mean you don't have to do math. Sorry about that. Alright, so these are our objectives. Make sure at the end of the presentation or the video, these are 2 things that you can do. If you can't or you don't feel comfortable with it, go back and rewatch or come back to the Microsoft Teams meeting if we're doing this live and ask a question. Okay? Alright, so remember our review vocabulary. We talked about what an experiment was a couple of lessons ago. So an experiment is just a set of controlled observations that test a hypothesis. So when we do an experiment, usually we collect multiple trials worth of data. So we won't just measure something once and call it good. We'll measure it 2, 3, 4 times just to make sure that the results that we're getting are consistent and we didn't make a mistake somewhere. So when we do an experiment, we take multiple measurements of the same thing. That way we can make sure that we're consistent. New vocabulary for this section is accuracy, precision, error, and then percent error. We're going to talk about all 4 of those here in just a bit. Okay, so what is accuracy? You might know the word already outside of the context of chemistry class, but accuracy just refers to how close a measured value is to an accepted value. So if, for example, I'm measuring my weight, and let's say I weigh 200 pounds, that's my accepted value because that's what I actually weigh. But if I get on the scale and it says 170, I'm thankful, but that's not necessarily accurate because I know for a fact that that's not close to my true value, right? So it's just how close you are to what the answer actually is. If you're throwing darts, maybe your accepted value is the bullseye. So if you throw at the dartboard and you're off the board, then that was not very accurate of you. Okay, so again, that's accuracy. Precision refers to how close a series of measurements are to one another. So if I get on the scale that tells me I'm 30 pounds lighter than what I actually am, and the scale tells me over and over and over again that I'm 170, those measurements are all the same and they're all close to one another. So that scale, even though it's off in accuracy, is really precise because it's giving me the same answer over and over. Okay, so in darts, if I'm throwing darts in the same spot on the board every single time, even if I'm off the bullseye, then it's still very precise. Okay, so precision just talks about if I do multiple measurements, how close are they to each other? If they're very close to each other, even if they're wrong, then precision is good. Okay. So looking at these dartboards here, you can tell if I throw a 1 dart and hit the bullseye, that's accurate. Okay. Notice it doesn't say anything about precision here because I've only thrown 1 dart. I have nothing else to compare it to. See, precision looks at multiple measurements, so if I only have 1 measurement, I can't say anything about precision. But I can say that this is accurate because I did hit the bullseye. Okay, on the second one, notice all 3 of my darts are in kind of the same spot, so you can say that those are very precise because all of my darts are close together. But look how far away from the bullseye I am. Not accurate. Alright, so something can be precise but not accurate, and this is what that looks like. Right here, I've got all of my darts very close together, but this time they're all in the bullseye, so we would say that this is both accurate and precise because they're close to the accepted value and they're all very close together. Alright, and then finally over here we have not accurate or precise. I have darts all over the board. They're not close together, so they're not precise, and they're not really close to my center or my bullseye, so they're not accurate either. Okay, so that is the difference between accuracy and precision. Now, I do want you to go ahead and pause and answer this question. Basically, look at this table. Student A's data is here, student B's data is here, student C data is here, and the accepted value is up here, the 1.59. So look at this table and evaluate each student's accuracy and precision and comment on those in your answer box. And then I'll give you feedback and we'll talk about anything that comes up if there's an issue. But go ahead and do that, pause the video, whenever you're finished, unpause, come back. Okay? Alright, so if you said that student A was both accurate and precise, then awesome job. You can see their average measurement was 1.57. The accepted value is 1.59, so that's very, very close. I would say that that's pretty accurate. It doesn't have to be dead on to be accurate. As long as it's within a reasonable amount, you can consider it accurate. And as far as their precision, all the measurements are fairly close together. There's not a huge difference between 1.54, the smallest measurement, and 1.6, the biggest measurement. So you can say that these are precise. Okay, student B, not accurate or precise. So here's their average, 1.51. That's a little bit further off. I would say significantly further off than this one from the true value. So I would say that that's not accurate. And look, their measurements are all over the place. You have 1.4, you have 1.68, so definitely not precise either. Okay, and then with student C, your measurements are all very close together, so these are precise, but look at your average compared to your accepted value. Not accurate. Okay, so it's a little bit further off than we would like it to be in order to call it accurate. Okay, so that's how you evaluate accuracy and precision of a data set like this. Next. Alright, so I want you to go ahead and take a second and think about how you're feeling about the difference between accuracy and precision. If it's something that you feel comfortable describing about a data set or something like that, then go ahead and drag your dot to the green. If you're a little confused, put it here in the yellow, and if you really need extra help, put it here in the red. That way I know where you're at. Okay, and we can, if you have any serious questions about this, you can come back into the Teams meeting if we're doing it live and ask. I'll answer them in real time. Otherwise, if you're watching this after the fact, just send me a message on Remind or shoot me an email or something and I'll help. Okay? Alright, so moving on. Now we're going to talk about the percent error part. So we've done accuracy and precision. Okay, so error is defined as the difference between the experimental value and the accepted value. So in other words, if I know that I weigh 200 pounds, just using that as an example again, that's my accepted value, but if my experimental says I'm 170, the difference there is 30 pounds. Okay, so my error would be 170 minus 200, and it would be actually negative 30, saying that my experimental is lower than what the actual value is. Okay, so error is pretty easy. It's really just asking the question, how much am I off by? And if you can answer that by subtracting numbers, then you're good to go. Okay? All right, then percent error follows this formula. So percent error expresses error as a percentage of the accepted value. So again, if I'm 200 pounds, using that as the example, and I'm 30 pounds off, well, I want to express that as a percentage of 200. So I would just do 30, which is my error, divided by the actual value, 200. 30 divided by 200 would give me 15%. Okay, so I can do percent error that way. Just take my error, drop the negative if it's negative. That's what these absolute value bars mean. You just take the positive regardless of what your number is. Okay, so take the absolute value of your error, divide it by your correct answer or your accepted value, times 100 to make it a decimal, to make it a percent, and then that's your percent error. Okay, so we're going to do an example problem real quick. Let me come over here to my whiteboard. This is slide 13, so you can see where I'm writing. Okay. And I'm here on my iPad, so please bear with me here. Make sure I'm doing this right. Okay, so the problem says 3 students were asked to measure a long piece of rope, which had an actual length of 500 feet. Okay, so this is some important information. Actual length or accepted value is 500 feet. Okay. Student A measured 503.5 feet. So we'll do A is equal to 503.5 feet. Student B measured 502.8 feet. And then student C measured 497.4 feet. All right, and then the question asks, what was the percent error? So I'm finding percent error of each student's measurement. Okay, so if I want to do that, I'm going to have to do the percent error calculation 3 different times. So let's do it for student A first. Let's just call it A percent error equals, okay? And if I go back to my formula, it is error divided by accepted value, okay? And remember that error is just experimental minus the actual, okay? So my formula for the percent error for student A would be the absolute value of experimental, so experimental for A is 503.5 minus the actual, which is this 500 feet, and then all divided by my actual. So all divided by 500 feet again. Okay, and let me actually zoom out here just a touch so you can see what I'm writing. Okay, all right, so once I do that, if I evaluate the top, I'm going to get 3.5 and divide by 500. And then don't forget the times 100 also is part of your formula. So times 100. And I don't know what that is off the top of my head, but let me get my calculator. Okay, so it'd be 3.5 divided by 500, and then times 100. And I'm going to get 0.7, and that's 0.7%. So 0.7% is the percent error for student A. Okay? All right, now I'm not going to work examples for B and C. What I'm going to do is just go ahead and give you the answer. And I'm going to let you pause the video and work those out yourself and see if you get the same. Okay? And if you don't get the same, maybe ask a question or something like that, or review the video or the calculation or something like that, just to see if you can eventually arrive there. Okay, so for B, it's going to be 0.56%. And then for C, it's going to be, for C, it's going to be 0.52%. Okay, so do the calculations on like your paper and see if you get these same answers. And if you do, then you're probably in pretty good shape with percent error calculations. And if you don't, then go back a little bit in the video and review the example and the formula. Make sure you know how to use it, okay? Alright, but I'm going to go ahead and move on. So that's it with accuracy, precision, and percent error. So I want you to go ahead and take time to answer this question. It says a student calculated the density of an object 3 times, got the following results. Here's the correct density, so talk about the accuracy and precision of that student's data. So go ahead and pause the video, answer that question, and whenever you're finished, come back. The answer will be on the next slide, which is coming up right now. Okay, so if you said D, neither accurate nor precise, awesome job. Obviously these are all over the place, so not precise. And if you take the average, you're going to get something that's pretty significantly off from 6.6. So take the average, you're not going to be accurate either. Okay, next question. Go ahead and do the percent error here. So finish this problem, and then pause whenever you're done, come back, and I'll show you the right answer on the next slide. Okay, and if you got D, 43.2%, then awesome job. And if you didn't, maybe go back and review the percent error part of the video, or come back and ask a question. Alright, so that is pretty much it. Go ahead and complete the exit ticket, complete the assignment in Canvas for this section. It's going to be due tomorrow. And if you have any questions, let me know. Thank you for watching, and I will see you later.